asymptotes. Asymptotes are lines on the graph that the graph of a function gets closer and closer to without touching or crossing, yeah. And we're talking like infinitely close.
That doesn't make any sense.
Why not?
How can it be infinitely close but not touch?
It's like,
See, it's like
you
we're
guys just gonna
infinitely
go
close.
0.000000, and it's just gonna keep on going on and on.
Exactly.
No, then that's like imaginary numbers.
Here, let me explain it.
When you get to calculus next year, there will be this thing called limits. So instead of saying, where does it get to but not quite get to, we just say the limit, or where it pretty much gets to because it's infinitely close. We pretty much just say that it gets to that point. But for this, we just say there's an asymptote there and it's never going to get there. It's just a guideline to help us graph stuff.
Like it makes sense.
Okay. Comment over there? No? Okay, there are vertical asymptotes. Vertical asymptotes in general occur where the domain does not exist. So what did we just barely get done doing? What did we just barely do? We learned about domain and how to figure out what x can't be, right? Well, that number, those domain numbers where x can't be, will be a vertical asymptote. Sometimes instead of vertical asymptote, it'll actually be a hole in the graph, and we'll talk about that in a minute. Okay. Occur where the domain does not exist. So the way to find vertical asymptotes is you set the denominator equal to 0 and solve. Only this time, instead of it being x does not equal those points, it's x does not equal that x value. It's x does equal, and it's a vertical line. Because if we have x equals a number, we get a vertical line, right? All right, so let's do a little example. Let's say we have, I don't know, I'm just pulling this out of the book. 8x squared minus x plus 2 over 4x squared minus 1. Let's find the vertical asymptotes. There might only be one, there might be more than one. So I'll just put parentheses around the plural. So what do we do? Okay, so I'm going to go 4x squared minus 1 equals 0. So 4x squared equals 1. So x squared equals 1/4. So x equals plus or minus 1/2. Does that sound right? So there are two vertical asymptotes. So if we were going to graph this, there would be a vertical asymptote at -1/2 and a vertical asymptote at +1/2, and the graph would go around those areas. It would not cross it. Well, I don't know exactly what this graph looks like, and if you try to graph it on your calculator, these are really hard to graph on the calculator because it doesn't really show them right. I don't know how it works on the iPod. That's an interesting question. Yeah. But on the calculator, it tries to connect it, and it makes them look really weird. But Sometimes it might look something like this. I don't know. That's just like a suggested possibility. That doesn't mean it's that graph. So, because there's other things to consider.
What were those called in the back of the function?
These are called rational functions. And the lines where they don't cross are called asymptotes, right? Asymptotes. Okay. There is one more thing, though, that we do need to deal with, because I did say something that I didn't write down. The places in the domain where it can't exist, like here, so there would be a vertical asymptote at x equals -3, right? Or there would be possibly a vertical asymptote at x equals -2. Although sometimes, instead of there being a vertical asymptote there, there's actually just a little hole in the graph. That will happen if you can reduce the fraction. Let me see if I can find one that does that. Dun, dun, dun. Sorry, I can't find what I want. I should pull out my other notes. Alright, I better just look at them. I'll find one that way. That'll work. Okay, let's try this one. F of x equals x squared minus 9 over x squared plus 4x minus 21. Okay, so when you're figuring out domain and asymptotes, you generally just look at the denominator. So we should factor the denominator, right? What will the denominator factor into?
7 and 3. Plus 7.
Good. X plus 7 and x minus 3. So would you say there might be a vertical asymptote at x equals -7 and a vertical asymptote at x equals +3? You would think so, right? But that's actually the domain. So let's talk about that, the difference between the domain and the asymptotes really fast. Domain would be not equal to -7 and not equal to +3, right? Asymptotes, you're thinking, would be equal to -7 and equal to 3, right? But let me show you why that's not going to be true. Let's look at the numerator. Remember how we didn't have to look at the numerator for the domain? Now we do have to at least glance at it for the asymptotes. Can I factor the numerator?
Yes.
What does it factor into? Guess what? That cancels. So there's actually only an asymptote at -7, and there's what we call a hole in the graph at 3. That means instead of it being a whole long vertical line that the graph follows the shape of, it just the graph goes to that point and then it doesn't exist right there and then it continues on. Is your graphing calculator going to show you a hole in a graph? No, because it would be one itsy bitsy teeny tiny point that your graph won't necessarily show. So you can't see holes in the graph by graphing with a calculator or an iPod. Okay? You have to know how to do that yourself. Why is there a hole? Because our original, they cancel out, so that means that the function won't be there. The function will just look like x plus 3 over x plus 7, so there will be no asymptote there. But even though those cancel out, so it's like as if they're not even part of the function, they were at the beginning. So that means that even though there's no asymptote there because it cancels out, you still can't plug in 3 because it would make the denominator 0. You can't do that. So it's complicated. That doesn't happen very often. You don't see those very often.